Hello guys, today we will discuss lead code question number 1930 unique length 3 palindromic subsequences. In this question we are given a string S and we have to find total number of unique palindromes of length 3 that are subsequences in the string. Okay, let's take the example 1. We have 3 different palindromic subsequences. How? We have one A, B, A, other is triple A, and the third one is A, C, A, right? There can be multiple instances of A, B, A, right? Like we can get A, B, A in multiple ways, but we want only the unique one, so the answer will be 3. Similarly, here also we have the answer 4. There are multiple ways to get the same string, like I can take B, B, and B, right? This two b's and this one b, also I can take this one b and this b and this b, right? So I just want one instance of every unique subsequence. Okay, so we have b, we have bcb, we have bab, and I have aba, right? So the output will be 4. Now how can I get this? Okay, so the first thing that we need to observe is that there are only 26 by 26 number of palindromic subsequences possible. Okay, how? We have we have these two equal, right? And they can be from A to Z, right? Total 26. Also here we have 26 ways, right, from A to Z. Okay, so which means that total will be 26 multiplied by 26 by 26. Okay, now what I am thinking to do here is that for each of these 26 by 26 subsequences, what I will do is I will simply find whether each of them exists or not. Okay, so how to know if any of the string exists as a subsequence? Let's say I have one example which is A, B, and A, right? And in this string I have, wait, okay, let's say I have here A, C, B, A, B, B, and B. Okay, here this B should be in between of any two A's, right? Also the occurrence of this A should be at least 2, and this B should be in between of any two A's. Okay, now how to ensure that this B is between A's? What I will do is I will keep track of the first occurrence and the last occurrence of A. So here A A's first occurrence is at index 0 and the last occurrence is at index 0, 1, 2, 3, at 4. Okay, at index 4. Now let's iterate through all the indices of B, right? So the indices of B are 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so the indices of B are 2, 5, 6, 7. Okay, let's check for 2. Is it between any two A's? Correct, right? So which it means that this string exists. Okay, this string exists. Similarly, we will do this for all the 26 by 26 substrings. Okay. Now how to implement this? What I will do is I will keep track of all the indices of A and B, C, D, E, F, etc. Right? Like for A, we have, oh sorry, this is C. Okay. Like for A, we have 0, 3, and 4. Okay. For B, I have 2, 5, 6 and 7. Okay, similarly for C I have only and only 1. For D I have nothing, for E I have nothing, and so on for every character. Okay, and then I will just find for A. First, the occurrence of A should be at least 2, right? In this example, occurrence uh, should be at least 2, and the occurrence of B should be at most uh, exactly 1 or more than 1. Okay, it cannot be 0 because we want it here. Also for A it should be more than or equal to 2 because we want two A's here, and that's why. Let's now implement this. In indices. Okay, we have done it. Now we will iterate through all the possible palindromic palindrome substrings. Okay, for that we will simply do this. Yeah, A is equal to A. Mm. These are the terminal characters. Okay, let's call it T instead. It will be small t less than equal to Z T plus plus. And this is mid. Now now this T should be at least 2, so we will put a condition here. If indices of T dot size should be greater than or equal to 2. Great. Same here, we want this should be more than or equal to 1. Okay, we have done it. Now what I want to do is I will iterate through all these M, all the indices of M, and I will check whether it's between the T, it's between the indices of T or not. Okay, let's iterate through all the indices. If I is more than or equal to indices T 0 and I is less than equal to the last occurrence of T, right? So T dot size or dot back, I will simply answer plus plus, and I will break because I will break out of this. Okay, break out of this. Okay, great. And I will in the end return the answer. Okay, why have I done this? Okay, let's try to understand. Here as you can see, let's split our screen into two so it will be easy to understand both through code and through diagrams. Okay, right, let's say I have this string. Okay, and I want to find A, B, A. Okay, so there are occurrence of A, some A's are here, some A's are here. Okay, and I have one B here. Okay, and one B is here. Great. Now I am iterating through the indices of B. These are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now indices for A are 1, 2, and 7 and 9. Great. For B, they are 0 and 5. Okay, great. Now, if any of these B's are in the range 1, comma 9, right, which are the extreme ends of the occurrences of A, it is sure that this can be made, right? That's exactly what I did here. I is more than or equal to indices T0 and I is, oh, I is less than here. Okay, because because it cannot be equal, so I is more than indices 0 and indices T dot back. So this I should be bigger than this one and less than 9, right? So this does not meet my expectation, but this does. Okay, so I will increment the answer and I will stop checking further, and yet simply return my answer. Let's try to run this code and check whether our new implementation is correct. Oh, it should be semicolon here, it should be semicolon here. Great. Yep, our test cases got accepted. Let's submit this code. Okay, and then we will further optimize this. Okay, we got accepted. Okay, great. Now I can further optimize this. I can improve this piece of code here. How? As you can see, this array of indices is monotonically strictly increasing. Okay, similarly this b is also strictly increasing, and I want exactly one index of b which is between 1 and 9, right? So what I can do is I can put a lower bound on b, and I will find an element which is bigger than 1 in b, right? So it will point to 5 and I will check whether this 5 is existing, and it's less than the a dot back. Okay, so let's do that. Upper bound. I need to use upper bound here because it cannot be equal to 1. So upper bound, indices t dot begin, indices t dot end. Okay. Indices m, right? I want to find in this m. This is m and this is t. Indices t dot m dot n, and I will find the first element. Okay, now if it is um, indices m dot end, like if it is pointing here, the iterator is pointing here, it means that none of these are bigger than 1, right? So that case is not correct. If it is equal to dot end, I will simply continue else if if value of it is less than this 9, right? Let's say we have the one of the index here is 15, right, which is bigger than 1. So now it points here, but this 15 goes beyond this 9, right? So it's not now between the terminal points of a. So I want this to be less than here. If value at it is less than indices of t dot back, I will just do answer like this. Okay, now let's run this code and we will discuss how my time complexity is improved here. Okay, this got accepted. Let's submit it. As you can see, my runtime dot got decreased here. Okay, now let's discuss how my time complexity got improved. Okay, before it was here a loop of these indices, right? We have to go through each and every indices one by one, right? But here I am using upper bound, so which is like the binary search on this b, right? So it decreases my time complexity here from linear to logarithmic. Okay, now my time complexity for this portion has become big O of 26 by 26, 26 by 26 by log of n. Okay, for this portion my time complexity is big O of n. Okay, so with this my worst complexity remains same, but the runtime has gotten decreased significantly. Okay, so here time complexity will be the maximum of this and this. Okay, this is how it goes, and this is my approach, and I hope you like it. So also leave the comments below for what part you didn't understand, and if you need any clarification for any part regarding any domain, like if you didn't understand the time complexity, this upper bound, or any of these lines. Okay, we will discuss it there. Thank you. Bye.